The average new car today has more computing power than the Apollo lunar lander had 20 years ago. With distributorless ignition, electronic fuel injection, and sensor-monitored computer-controlled actuators, you need the most accurate, sophisticated, easy-to-use diagnostic power you can get to trace and identify elusive problems, solve them fast, and keep your customers satisfied. The Snap-on Counselor 2 gives you the diagnostic power you need in this all-new generation of digital oscilloscope technology. This video provides basic operating procedures for the Snap-on Counselor 2 digital oscilloscope. You'll get acquainted with the scope's physical characteristics. Understand how the scope's special features and functions aid the testing process. Learn how to set up and conduct each of the diagnostic tests. And get some helpful troubleshooting tips. You'll find detailed information about all of these procedures in the Counselor 2 instruction manual. Veteran auto technician Bill Large demonstrates how to use the Snap-on Counselor 2. Bill has been in the automotive field for more than 25 years. He owned his own shop for 11 years and is an ASE certified master automotive technician. At Snap-on, Bill has been an automotive engineering technician, a product promotion trainer, and he's currently a product analyst in marketing research.
The Counselor 2 is designed to be easy to use, and you can learn as you go. You don't need a lot of training to start using the scope. You can get a lot of information just by looking at the screen because the test patterns are very straightforward. With time and experience, you'll get even more diagnostic information from the test patterns. You decide which tests you want to use and the order you want to do them in. You can move from screen to screen in any order. You can quit a test at any time and start over. You'll get prompts on the screen asking you questions or telling you what to do next. You'll get an error message when you do something wrong, and you can get help whenever you need it, anytime, any place. Plus, there are lots of ways to customize the information to suit your own individual needs and preferences. Let's take a quick look at the scope's physical features and what you'll be working with. When you're using any piece of diagnostic equipment, you should always wear safety glasses and observe standard garage safety. The scope's exterior is a tough metal and polymer shell that's designed to protect the scope's computer against damage in the shop environment. The scope is relatively small, 12 inches high, 19 inches wide, and 25 inches deep. It only weighs 42 pounds, so it's easy to carry. Be careful to position the scope securely when you're using or storing it. Don't place it on a fender where it might fall during a test. The KR495 roll stand offers convenience and mobility. Inside the scope, you'll find a variety of modular computer parts, similar to those you'd find in any personal computer. The on-off power switch is on the side. On the back, you'll find the AC/DC selector switch. You can power the scope by a standard 120 or 240 volt, 50 or 60 hertz, single-phase AC outlet in the shop, or by a 12-volt battery when you want to take the vehicle out for a road test. The AC power cord plugs in here. The DC power cord plugs in here. You can store the power cord conveniently on these hooks. This is the fuse holder. You'll need an alternate fuse for 240-volt operation. Here we have a couple of circuit breakers, one to protect the lead set ground, the other for DC power. Use the parallel port to connect the scope to a Snap-on MT3010 Scribe 2 printer for a permanent record of the test results. Use these two serial ports To connect a scope to equipment like the Snap-on MT2500 scanner or the MT3100 4-gas exhaust analyzer to display a variety of related diagnostic information. The serial ports will accept equipment that's RS-232 compatible or features a Snap-on VT100 subset. The Counselor 2 has RGB color output capability. You can connect the scope to most color computer monitors or video equipment that accept an RGB signal. This is an extremely useful feature when you're teaching in a classroom environment. The inductive pickup loop lets you use auxiliary test equipment like a timing light or timing advance meter that's equipped with an inductive pickup lead. These three terminals let you connect auxiliary test equipment to the scope when you're using DC power. They're not functional when you're using AC. The Counselor 2 uses a simple 6-lead harness to obtain the electrical signals from the engine that are needed for the various test screens. The lead set plugs in here. The black lead is the ground. It will attach to the battery's negative terminal. The white lead picks up battery, alternator, or voltage signals. Attach it to the battery's positive terminal or move it to the voltage test point. The yellow lead picks up signals from the primary ignition system and the fuel injector. It can be attached to the tach terminal, negative side of the coil, or fuel injector harness. The red inductive lead goes over the number 1 cylinder spark plug wire. The secondary adapter will go over the coil wire when there's an external coil, or will attach to the distributor for internal coils. Special adapters are available for GM, Honda, and Toyota ignition systems. The 6th lead has a Canon connector, so it can be connected to the leads that are used with the lab scope and optional test screens. The lab scope screen uses this auxiliary lead to get a signal from the sensor or any voltage source that you may want to test. The cranking amps bar graph screen requires the cranking amps probe, which connects to the battery cable. This probe is an optional item. A transducer is used to pick up intake manifold vacuum for the vacuum waveform screen. The optional power balance probe features a wheel that monitors engine speed by relaying fluctuations in the speed of a taut crankshaft belt. The circuitry for testing distributorless ignition systems is built right into the scope. Connecting the lead set is easy. All you have to do is plug the secondary lead into the DI terminal block and connect the dual capacitive pickups to the spark plug wires. Keep the clips of red-coated leads together and away from the clips of white-coated leads. If the test pattern jumps around on the screen, turn the engine off and move the two groups of clips further apart. The DI lead set is available as an optional item. Never puncture an ignition wire when you're connecting test equipment. When you're conducting a road test, be sure the Counselor 2 is turned off before connecting the DC power lead to the battery. Be sure the lead set will not come into contact with hot or moving engine parts. Run the lead set out from under the hood and through the passenger side window. Fasten the hood securely, but avoid damaging the lead set. You should never attempt to operate the Counselor 2 and drive the vehicle at the same time. You will find complete instructions for connecting the Counselor 2 to a variety of vehicles in the Counselor 2 instruction manual. The scope's front panel is self-explanatory. The large 12-inch monitor takes up over half of the front. It's easy to see test patterns and read text even at a distance. This knob controls the brightness. The silicone keys are sealed to keep dirt and grime out and make them easy to clean. Keys are grouped together by function. They're labeled and color-coded to help you find the ones you want quickly. Let's take a look at the different groups of keys. The green keys are the menu keys. They will take you directly into the diagnostic test menus. From here you can go to the test you want to do. Menu keys also take you to the scope setup options, memory, and help screens. The red reset key enables you to restart the scope's computer just as if you turned the power off and on. These keys are called feature keys. Feature keys give you the ability to interact with the information you see on the screen and modify it in certain ways that make it more useful to you. The 4 arrow keys let you move the highlight cursor around the screen. You can also use them to change the size of a test pattern or its position on the screen. We'll talk more about these capabilities in the Features and Functions section. You enter data or changes by pressing Enter. The 4 red keys are specific command keys that can be used in many test screens. You can enter RPM set points where a test will automatically stop when the engine reaches a predetermined speed. You can freeze a live test pattern to examine it more critically or save it in memory. In certain test screens, the Select key will give you access to additional testing options. And once your printer is set up, you can print any screen, a live test screen or one that's stored in memory, simply by going to that screen and pressing the Print key. To stop printing while it's in progress, simply press the key again and hold it down for about 5 seconds. You enter engine information with the numeric keys. The F keys or function keys are very versatile. They will give you specific options that are tailored to the screen you're in, so what they do changes from screen to screen. The labels for the keys are on the screen itself. The advantage of this arrangement is you don't need a lot of keys to operate all the different screens of the Counselor 2, so the keyboard stays small. F6 will almost always take you back to the menu screen, unless it tells you otherwise. This smooth disc is the lens for the optional infrared remote control. The remote control has the same keys you see on the front panel, except for the red reset key. You can operate the scope from across the room or inside a vehicle. There are only 2 things you can't do with the remote: turn the scope on or off, or reset it. The Counselor 2 has many special built-in features and common test screen functions. They will make the testing process easier and more convenient for you as you learn to use them to your advantage. First of all, when you run into a problem or have a question, help is always available right where you're working. The Help key puts a lot of information that's in the instruction manual right at your fingertips. It doesn't matter which screen you're in. Press Help and the scope will automatically go into the portion of help that pertains to the screen you're working in. The entry title's at the top. These arrows tell you that there is more information on the next screen. Keep going until you come to a solid line. That signals you're at the end of that entry. When the arrows are at the top, they're telling you that there's more information on the previous screen. The Help entry tells you what the test screen is designed to do, how to access and exit the screen, and what special functions are available for the screen. The active feature keys are identified. The leads and connections are listed, and you get additional notes that will help you conduct the test. If you want more about a particular feature or function, go into the Feature Function Help menu. Use the arrow keys to highlight the entry and press Enter to access information about that feature or function. You can find out more about other screens by pressing Screen Help menu, using the arrow keys to highlight the screen you want, and pressing Enter to access help on that screen. Return will always take you back to the test screen you were working in. This built-in help is extremely useful when you need to know something in the middle of a test. Before you actually begin using the diagnostic tests on the Counselor 2, go into the Option menu and select Scope Setup. Set the current time and date. This information will appear on all of the test screens, and they're handy references later on when you've printed or stored the test results in memory. You can turn a beeper on to sound every time you press a key. You can turn an error message on to alert you when the scope detects a processing error. Use communication port to select and set up the serial and parallel ports. You can turn key indicators on to show you when you can use the arrow and select keys, and to give you a prompt on some test screens that tells you which lead to use. If you're using peripheral equipment like a scanner or printer, set the baud rates to communicate with that equipment. The option menu offers 2 access screens for the display and control of information coming through the scope's serial ports. We'll talk about the scope's self-diagnostics function later when we cover troubleshooting tips. At certain times, it will be helpful to see how the ignition performs during acceleration and deceleration. It can be awkward to try to alter engine speeds and monitor activity on the scope at the same time. Setpoint lets you preset RPMs where the test pattern will freeze automatically when a defined RPM is reached. You can recall the pattern after the test is done and analyze it in detail. To preset an RPM, press Setpoint and follow the instructions on the screen. You can set 1 or 2 RPMs, Setpoint A and Setpoint B. You can decide to capture the pattern during acceleration or deceleration for one or both of the set points. When you return to the test screen, a prompt tells you which set points, A, B, or both, have been programmed. The arrow tells you whether the pattern will freeze during acceleration or deceleration, and you have the RPM. Armed indicates that you're ready to go. Frozen will replace armed when you've reached the set point RPM. When you've finished the test, go back into set point and select View A or View B to recall the pattern. The screen prompt will say Frozen A or B to indicate which pattern you're looking at. There will be times when you'll want to measure a waveform or portions of a waveform to see how much and where the pattern you're getting is varying from other waveforms or the manufacturer's specification for normal operation. This will help you pinpoint problems and eliminate areas of concern. The Counselor 2 has several screen functions that are designed to help you estimate or actually measure the size of a waveform pattern. Turning any of these screen functions on or off does not affect the signal from the vehicle or the pattern on the screen. Also, it's often helpful to freeze the test pattern while you're trying to analyze it. Simply press freeze again to return to a live pattern. In all 8 waveform screens, you can turn a background grid on to display incremental divisions of time and voltage, or in the case of the vacuum waveform, incremental degrees of rotation and vacuum. You can turn cursors on to measure the actual difference in time or voltage between any 2 points of a waveform. There are always 2 sets of cursors on the screen. The solid cursors are active and can be positioned on some point of the waveform. As the indicators show, use the arrow keys to move the active cursors around the screen. The broken cursors are marker lines. Use the select key to switch the cursor from active to inactive. The measured difference between the active cursor and the inactive marker line is displayed at the top. You can compress a waveform or expand it with the waveform size select function. Use the left arrow key to compress a waveform that's too wide for easy viewing. Use the right arrow key to stretch out a short waveform so you can see more detail. Note that the time scale changes as you compress or stretch a waveform. The vertical scale is not affected by this change. The waveform position lets you use the arrow keys to move the waveform on the screen for better viewing. This is especially helpful when you want to view a certain portion of the pattern. Several of the bar graphs will let you review the test results on more than one scale. Use Range Select to choose a scale that's appropriate for the vehicle you're testing or to isolate a problem. When you freeze a screen or when a pattern freezes automatically, the information is only stored temporarily. If you want to keep the test results for a longer period, you must store the test screen in memory. To do that, freeze the test screen you want to store, then go into the Memory menu. The test screen you were working in will be highlighted. Each of the 15 test screens has two memories, Memory A and B, where data can be stored. Use the left or right arrow key to select the memory you want to use. Press Save Screen. The date and time appear to identify the stored screen. Return will take you back to the test screen. When you want to recall the stored information, go into the Memory menu. Use the arrow keys to highlight the entry and press Recall Screen. A prompt tells you you're in Memory A. Press Memory menu again to return to the menu. To remove the entry, select it, then press Clear Memory. A prompt tells you what to do to clear more of the scope's memory. If you press Clear Memory 3 times, you'll clear all of Memory A. If you press Clear Memory 5 times, you'll clear the entire memory. If you have the Snap-on Scribe 2 printer, you can print out a hard copy of any screen at any time. It's often helpful to refer back to a printed test pattern later. Create vehicle history files to encourage repeat business. When you press the print key, whatever is displayed on the screen will be printed. To stop a print command, press Print again and hold it down 5 seconds until the printer stops. Now let's look at what's on each of the screens you'll encounter when you're setting up and conducting the diagnostic tests. First, note that each screen has the current time and date. Remember, this is the reference you'll use later on when you print the test results or store a screen in memory. The first screen, the Snap-on screen, will appear each time you turn on the scope. The Counselor 2 will test virtually any vehicle on the road with engines ranging from 1 to 16 cylinders. The scope asks you to enter information for the engine you are going to test. Follow the instructions on the prompt. Press Modify Engine Data. Enter data with the numeric keys. The highlight cursor automatically jumps to the next entry. If the information on the screen is correct, simply press Enter. Since the numeric keys only go up through 10, with the 0 key entering 10, you must use the F keys to enter a number from 11 to 16. Remember, if you need help at any time, press the Help key. After you've entered all of the engine data, it's a good idea to review the screen and verify that the data displayed is correct. Now you're ready to go into any test. To come back to this screen, press F6 to return to the menu. Press F6 again to return to Start. The primary menu offers 3 diagnostic test screens: the duty cycle bar graph, dwell bar graph, and the primary ignition system waveform screen. The duty cycle bar graph displays the fuel system dwell or duty cycle of the mixture control solenoid on electromechanical carburetors. A screen prompt tells you which lead to use. For this test, the white lead. The dwell or duty cycle is displayed in % across the top and degrees on the bottom. You can view the test bar on a 60-degree or 90-degree scale. Frequency is displayed in hertz. You can use it to verify the number of signals per second sent to the mixture control solenoid or frequency valve. A second test screen displays duty cycle on a voltage scale for systems that require that type of measurement. The dwell bar graph displays in raster form the amount of time that the ignition coil primary circuit is turned on. That time is displayed in both degrees and percent to accommodate the way dwell is specified by both domestic and foreign vehicle manufacturers. Degrees appear across the top of the graph, percent at the bottom. Each cylinder is presented in firing order. The information is displayed in both graphic and numeric form. The screen also gives you the RPM, average dwell, and average duty cycle. Use the clear key to zero out the bar graphs and numbers so new information can be displayed. The live primary waveform screen displays what's happening electrically in the ignition primary circuit. Information will be presented in cylinder firing order. The one that's highlighted is the one you're looking at. The RPM and dwell are displayed. You can expand the waveform or compress it and move it around for better viewing. You can turn on a grid to help you measure the waveform against a scale or look for variations in the pattern. The grid divides time into increments that change with engine speed and voltage into 50-volt increments. Cursors will help you measure select portions of a live or frozen waveform. You can also opt to inspect a single cylinder or a parade of waveforms for all the cylinders. The value of these options is discussed in an optional video on test pattern interpretation. The secondary menu takes you into 4 diagnostic tests: the burn time bar graph, kV bar graph, kV histograph, and the secondary ignition waveform. The burn time bar graph displays in raster form the secondary ignition spark duration for all cylinders. This is the length of time in milliseconds that a spark arc is sustained between the electrodes of a spark plug. It corresponds to the period of the secondary waveform from the peak firing through the current flow portion of the waveform to the point where the energy can no longer be sustained. The RPM is displayed. Cylinders are listed in firing order. The minimum, maximum, and live burn times are given in digital form. Live burn times are also displayed in graphic form to help you compare each cylinder's performance. Press F1 to clear existing data. You can choose a bar graph range of 0 to 2 or 0 to 4 milliseconds. The kV bar graph shows the changing amount of voltage required by the spark plug when it's firing. The live voltage requirement is shown as a bar graph, while the maximum and minimum voltages are listed as numeric values. The cylinder firing order sequence is listed here, and the RPM is displayed during the entire test. Range Select gives you 2 scales for viewing the live pattern: 0 to 15 kV or 0 to 30 kV. Press Clear to zero out the graph and numbers. The kV histograph displays 256 consecutive spark plug firings for each cylinder, allowing you to see intermittent misfires and whether the firing voltage goes high or low at any given point. The RPM is displayed and the cylinder firing order given. Range Select gives you 4 kV scales from 0 to 10, 15, 25, or 50 kV. Select the range that will position the histograph midway in the scale. The oldest data moves off the left of the screen as new data appears on the right. You can change the cylinder you're viewing at any time by pressing the corresponding numeric key. Cylinder Scan will let you watch the activity in all of the cylinders. The scope automatically displays a different cylinder every 1.5 seconds. If freeze is pressed during a scan, the scope will record data for all of the cylinders while the scan is going on. You can review all of the histographs after the test is finished. The true wasted key is used to compare patterns of true firings to those of wasted firings when you're testing engines equipped with distributorless ignition. Press Clear to remove old data. The secondary waveform monitors the voltage of the secondary ignition system from the coil to the spark plugs. The RPM, cylinder firing order, and kV for an individual cylinder are displayed. The single pattern displays the secondary waveform for only one cylinder. That cylinder's kV requirement is also given in digital form. The parade pattern displays the secondary waveforms for all of the cylinders at once. The cylinder that's highlighted is the one whose kV value is shown. You can turn on a background grid and cursors will help you measure select portions of a waveform, whether it's live or frozen. You can expand or compress the waveform and move it around for better viewing. The diagnostic waveform menu gives you 4 different ways to test the electrical integrity of the vehicle: alternator, fuel injector, and voltage waveforms, and a fully functional lab scope. The alternator waveform tests the quality of alternator output to verify that the internal operation is working properly. A prompt tells you to use the white lead for this test. The RPM is displayed, and the alternator output is displayed in volts and as a waveform. The voltage reading can be used to check the charging system's regulated voltage. The waveform will help you analyze the condition of the diodes and stator windings, 2 common sources of alternator problems. The background grid divides the scale into time increments in milliseconds that vary with engine speed and voltage increments of 100 millivolts. The fuel injector waveform tests the electrical integrity of the control signal to the fuel injector, which provides fuel delivery. The RPM is displayed, and a prompt tells you to use the yellow lead for this test. The background grid divides the scale into increments of time that vary with engine speed and increments of 20 volts. The voltage waveform displays signals to or from devices like cam, crank, and throttle position sensors. You can use this test to isolate problem areas or locate faulty components. The voltage waveform screen can be used to check and measure most signals generated by electric circuits and components, so it will help you stay current with evolving technology. RPM and voltage are displayed numerically. A prompt tells you to use the white lead for this test. Since the waveform may have a tendency to drift off the screen, you can stabilize it with an internal automatic trigger or use engine sync to synchronize it to the firing of the number 1 cylinder. The background grid divides the scale into increments of 5 milliseconds and 5 volts when engine sync is selected. When you're using auto trigger, you can use the waveform size option to view the waveform on time scales ranging from 5/10 to 20 milliseconds. The new lab scope screen gives you the same sophisticated testing ability that electrical engineers use when they're designing electronic equipment. The lab scope screen offers a lot of flexibility and adjustability for measuring the input and output signals found on today's complex automotive systems, whether the signal is to, from, at, or between one or more electrical or electronic devices. The dual trace function lets you monitor signals that are supposed to be synchronized with each other, such as camshaft and crankshaft sensor signals. The RPM and voltage are displayed. A prompt tells you to use the auxiliary lead for this test. When you're conducting a dual trace, use the white lead on the second signal. You can turn a background grid on, and cursors help you measure portions of the waveform. In the volts range, there are 6 options for the voltage scale, ranging from 200 millivolts to 10 volts. In time base, there are a dozen options, ranging from 50 microseconds to 200 milliseconds. You can use the arrow keys to reposition one or both of the waveforms. Use the select key to toggle between the two. Menu select gives you access to the setup parameters listed at the top of the screen. Use the arrow keys to move from line to line and the select key to scroll through the options for each parameter. The trigger slope can be positive or negative. A default setup gives you automatic parameter settings to help you get a waveform on the screen for evaluation. If you have trouble with a manual setup, you can always go directly to the default setup. Choose AC or DC for signal coupling. The waveform can be single or dual. There are 6 triggering sources: primary, secondary, number 1 cylinder, run, and auxiliary. When conducting a dual trace, the white lead can also be a trigger source. Signal invert turns the waveform upside down for a different view. The cylinder test menu gives you a variety of ways to test the power contribution of the cylinders and verify electrical and mechanical integrity. The tests include the cranking amps bar graph, cylinder shorting bar graph, cylinder time balance bar graph, vacuum waveform, and power balance waveform. The cranking amps bar graph checks cylinder contribution. It can be used on engines equipped with a distributorless ignition system in place of the cylinder shorting test. RPM and amps are displayed numerically. The cylinder firing order is given, and required amps are displayed in numeric and bar graph form. Each test bar is identified at the bottom of the screen. Zero out the numeric and graphic data with the clear key when you want to enter new data. Range Select gives you 3 scale options: 0 to 150, 75 to 225, or 150 to 300 amps. Press Start Test when you're ready to begin. The probe needed to conduct this test is an optional item. The cylinder shorting bar graph displays the contribution of power for each cylinder. Power contribution is compared through RPM drop as each cylinder is kept from firing. There are 2 RPM readings. The top one is live at all times. The bottom freezes when shorting occurs. The timer indicates how long each cylinder is being shorted. Cylinders are listed in firing order. The RPM drop and the amount of time required to short the cylinder are displayed numerically. The bar graphs show decreases in RPM as solid bars and increases in RPM as open bars. Use the clear key to delete old information. You can view the RPM drop on a 0 to 150 RPM scale or 0 to 300 RPM scale. You can short the cylinders manually, or you can have the scope do it automatically with auto shorting, which is set up to short a cylinder for 5 seconds, then wait 5 seconds before shorting the next cylinder. To short cylinders manually, press and hold the corresponding numeric key. Cylinders will be shorted for the length of time the key is held down. If the vehicle has more than 10 cylinders, select the additional cylinders by pressing Select Cylinder and short them with the Short Cylinder key. Even-odd shorting takes you into a second screen. The even-odd shorting screen is similar to the individual cylinder shorting screen, except that shorting is done in even or odd groups to test carburetor balance. Shorting can be done automatically by the scope or manually with the even shorting and odd shorting keys. The even and odd groupings refer to the cylinder's position in a numeric sequence, not to the numbers that identify the cylinder's firing order. The cylinder time balance bar graph displays the time between each cylinder's firing in milliseconds. A variance in the time for any single cylinder when compared to the average time for all cylinders can reveal mechanical wear on the distributor shaft, housing, and bushings. Excess slack in the timing chain will also show up. This test can also be used on vehicles with distributorless ignition systems to verify primary triggering consistency for Hall effect and variable reluctance sensors. The RPM and average time between cylinder firings are displayed. The average interval is represented by the center dividing line designated 0. Cylinders are presented in firing order. The time lapse between firings is given in numeric form n% difference. Times that are less than average result in negative differences. Times longer than average result in positive differences. Use the clear key to delete old data. Range Select offers 4 scales from 0 to plus or minus 1%, plus or minus 2%, 4%, or 10%. Usually, the 10% scale is used with 1, 2, 3, and 4 cylinder engines. The 4% scale with 5, 6, 7 cylinder engines. The 2% scale with 8 cylinder engines, and the 1% scale with larger engines. The vacuum waveform test screen monitors the fluctuations in intake manifold vacuum through a complete engine cycle. It's a check of the mechanical integrity of the intake valves, intake manifold, piston rings, head gaskets, pistons, camshaft, push rods, rocker arms, and cam followers by evaluating the engine's ability to develop vacuum or negative pressure. The probe needed to do this test is an optional item. The vacuum probe must be zeroed each time it's used to ensure accurate measurements. RPM and average vacuum are displayed at the top of the screen. The ignition firing order is displayed across the top. The vacuum event order is displayed at the bottom of the screen. Note that the sequence is different from the ignition firing order. This background grid, unlike other grids, displays degrees of rotation and increments of pressure in inches of mercury or kilopascals. Cursors will help you measure portions of the waveform. The vacuum probe 0 calibrates the probe to display 0 when no vacuum is being applied to the probe. Vertical position allows you to move the waveform up or down with the arrow keys. AC-DC coupling toggles between the two. In AC coupling, you'll get a waveform. In DC coupling, the scope behaves like a vacuum gauge. There are more options on the next page. Vacuum can be measured in inches of mercury or kilopascals. Waveform size lets you increase or decrease the amplitude of the waveform with the up or down arrow keys. Previous page takes you back to where you were. The power balance waveform displays the instantaneous engine speed changes that occur as each cylinder fires. A power balance test can be performed on any type of engine, including diesel engines, but is specifically designed to measure cylinder contribution in engines where shorting is difficult, if not impossible, to do. The probe wheel relays subtle changes in the speed of a moving crankshaft pulley belt, eliminating the need to disconnect or bypass control systems. Use the power balance test on computerized engine systems that automatically compensate for RPM loss. The probe required for this test is optional. RPM is displayed. A prompt tells you to use the auxiliary lead. To capture a waveform, press the red freeze button at the end of the probe handle. Do not attempt to operate the probe and analyze the waveform at the same time. The cylinder firing order is displayed at the top of the screen as ignition. At the bottom, the power stroke is identified as cylinder. The cylinder's power pulse should occur in the corresponding cylinder zone. The background grid displays time as degrees of crankshaft rotation and increments of relative amplitude that will help you compare waveform peaks. Cursors will help you evaluate portions of the waveform. Use waveform size to increase or decrease the amplitude of the waveform with the up and down arrow keys. Vertical position allows you to move the waveform up or down on the screen with the up or down arrow keys. You can manually select and short individual cylinders to demonstrate how a non-firing cylinder will affect the waveform. To short a cylinder, press and hold a corresponding numeric key. Cylinders will be shorted for the length of time the key is held down. If the vehicle has more than 10 cylinders, use Select Cylinder to select the cylinders with higher numbers, and use Short Cylinder to short them. The Counselor 2 is built to last and work reliably. But if something goes wrong, let's look at some of the things you might do to correct the situation. First of all, if the screen is completely blank, press Reset to restart the scope's computer. Check to see if the scope is turned on and plugged in. Is the power source working properly? Is the cord connected securely to the scope? Is the fuse okay? Is the voltage correct? Is the brightness control turned up high enough? If the screen's working, but you're not getting a test pattern, check your lead connections. If the lead set is attached properly, but it's not picking up a signal, check the continuity. This test is described completely in the Counselor 2 instruction manual. If the continuity test is good, try different pickups. If the test pattern is jumpy or unstable, first verify that the black ground clip is connected to the negative battery terminal or another good ground and press Reset. Try replacing solid core ignition wires with the radio suppression type and reroute test leads away from sources of radio frequency interference. If the test data seems to be incorrect, check the lead set connections. If the connections are okay, check the continuity. Once again, you'll find instructions for this test in the Counselor 2 instruction manual. Press Reset and check the snap-on screen to be sure the engine information is correct for the vehicle you're testing. Sometimes internal electronic lockup will cause the screen to freeze or prevent you from moving to another screen. Press Reset when this happens. If a problem isn't easily solved, you may want to use the Counselor 2's self-diagnostic capability. Here you can do an internal test to verify the scope's system software and internal operations are functioning correctly. You can check the signal coming through various leads and engine connections with the input test. And you can verify that the keyboard and remote controls are working properly. Check the Counselor 2 instruction manual for more help in troubleshooting problems. If any problem persists, call your Snap-on representative. Like all diagnostic equipment, the Counselor 2 carries the Snap-on Good as Gold warranty, covering parts and labor for 1 year from the date of purchase. Any repair that's needed will be done by qualified technicians at a Snap-on service center near you. As a final word of caution, never place liquids on top of the scope because they can damage the computer. If liquid should get inside, unplug the scope and don't use it until it's been thoroughly checked out by a Snap-on representative. You'll find more safety information in the Counselor 2 instruction manual. The Counselor 2 digital oscilloscope provides diagnostic information that can be used to alter the performance of the vehicle you are testing. Be sure you understand the meaning of the information you are obtaining before using it to service a vehicle. If test data should appear to be incorrect, check the Counselor 2 instruction manual or contact your Snap-on representative. This concludes our presentation on the basic operating procedures for the Counselor 2 digital oscilloscope. An optional video on test patterns interpretation presents strategies for using the various tests and shows you how abnormal test patterns reveal specific ignition system problems. Test pattern interpretation is available through your Snap-on representative. The Snap-on Counselor 2 gives you all the diagnostic power you need to trace and identify ignition problems, solve them fast, and keep your customers satisfied.